Okay, we have a question here to find the gradient of line L and differentiate the parabola there, P. Okay, so to find the gradient, you just look at the points that they gave you, 1, 1, and 2, 3, and we just plug them directly into the gradient formula, which is in the formula booklet. Okay, so there you got it. M is equal to y2 minus y1 over x2 minus x1, rise over run. So I'm just going to say M is equal to 3 minus 1 over 2 minus 1. Okay, so again, the numerator is the y values, 3 and 1. The denominator is 2 minus 1, and I get a gradient of 2. All right, differentiate f of x. Again, I'm going to use the formula booklet and the power rule, topic 7. So differential calculus, we're going to take the derivative of each term respectively because it's a sum, and we're going to take the exponent, take it down front, multiply the coefficient, leading coefficient by the exponent, and then we're going to take away 1 from the exponent. Okay, so that is the power rule. All right, so let's look at our function again. We got an x squared minus 3x minus 4. F prime of x, the derivative function, is you're going to take the 2 down front on the first term. So you see this exponent 2, you're going to take it down front and you're going to multiply it by the term. Then we're going to reduce the power by 1. So the derivative of x squared is 2x. And what is the derivative of negative 3x, next term? Well, you can just say it's a linear function and it's the number in front of x is the gradient, or you can consider that the power rule that we have an exponent of 1 here that you don't see. I'm going to take that down front, 1 times negative 3, and then the power of x, the power of the x is going to be 0 because this is to the power of 1. I'm going to take 1 minus 1 for the exponent. X to the 0 is 1. Okay, so my exponent, my derivative function just ends up being 2x minus 3. So that is the slope, the gradient, anywhere along the parabola. Here you can see there's a negative slope going through the vertex here where the slope is 0, and then it's increasing once we're on the other side of the vertex. The gradient of the tangent line is increasing. Okay, so the next question, is to ask for the point where the tangent line is going to be. So it looks like I forgot the last term here. My apologies. We took the derivative of x squared, that was 2x. The derivative of negative 3x was negative 3, but we forgot to differentiate. I forgot to differentiate negative 4. Well, 2 ways to look at it. Does negative 4 ever change? What is the rate of change of negative 4? It's 0. It never changes. Derivative of a constant is 0. Or I could use the power rule. There's an invisible x to the 0 here because that's 1. Okay, so I take the exponent, 0, multiply 0 times 4 to the power of whatever x is. It doesn't matter. 0 times anything is 0. So the derivative of this last term is 0. So that's why I only had 2 terms in the derivative function. You can notice that the derivative function, the number of terms might be reduced. If there's a constant term, they disappear, and each of the exponents was reduced by 1. parallel to line L, okay? So line L has a gradient of 2. We have a gradient function for line P. Let's just set them equal to each other. So again, we're looking for where on the parabola is the gradient 2. Solve this equation. And when I solve that equation, I get x is equal to 5 over 2. Now, I know the x value. I need to find the y value. So I'm going to take the 5 over 2, and I'm going to plug it into my original function up top, up here. So anywhere there's an x, I'm going to put 5 over 2 in this function here, okay? And then I'm going to get the y value at that point, okay? So again, y is going to be 5 over 2 squared minus 3 times 5 over 2, I think it was minus 4, okay? So when you do that calculation, you get the coordinates as the x value is 5 over 2, and the y value is negative 21 over 4, or negative 5.25. Okay, so that's the answer to C. Putting boxes around my answer so they're easy to find for the examiners. Question D, find the coordinates of the point where P is perpendicular. The tangent to P is perpendicular to the line L. So basically, we're looking for a line that crosses L at a right angle, something like that. Okay, and again, we're going to find the x value. The x value. So definition of perpendicular is the negative reciprocal. So I'm just going to take the negative reciprocal of our original function. We'll say m2 is equal to negative 1 over m1. All right, so what is the perpendicular gradient? Negative 1/2. Okay, and again, I want to follow the same procedure that I did just above there in C, and I want to find out where on the parabola is the gradient negative 1/2. So just take your gradient function and solve that, okay? And now we're going to solve that, and we'll have the x coordinate. We plug that x coordinate into f, function f for the parabola, and we find the y coordinate. Same procedure that you just did on C. So again, I solve for x here, and I get x is equal to 5 over 4. Strange, it was just 5 over 2 before. And then I'm going to plug 5 over 4, substitute it into function f, and y is going to be equal to negative 6.1875. What is that? Something over 16. So I'm just going to use the decimal that I have from my calculator. Okay, and I'm going to make the coordinates 1.25 this time and negative 6.1875. Okay, sorry, 1.9 if I wish, if I want 3 significant figures. Okay, so there's the answer to D. Question E, find the gradient of the tangent to P at the coordinates x equals 2, y equals negative 6. Okay, so all I have to do is evaluate the gradient function at x equals 2. Again, 2x minus 3, x is equal to 2, and the gradient is going to be 1. Okay, so again, if I look up at my parabola, I'm going to see somewhere, again, along the parabola, the slope is going to be 1. Okay, here it was 2, here it was negative 1/2 over here. Okay, so again, just to the right of the vertex, the slope is going to be positive 1. All right. So all we have to do is solve the equation a third time. 1 is equal to 2x minus, sorry, we did that already. The equation of the tangent line, we needed to find y. I already got what I needed. Excuse me. So I have m here. I have the point P 2 comma negative 6. Again, I'm a big fan of the point slope version for straight lines, linear functions. So I'm just going to use this version of a linear equation, and I'm going to find the function for y. 1 times x minus 2 plus y1 negative 6. And if I want to expand and simplify, mx plus c, x minus 8. Okay, if I wanted to simplify, it's not necessary. It just says give an equation. It doesn't say what form or simplify. Okay, the equation of the axis of symmetry, back to the formula booklet. The third time, right there, x equals negative b over 2a. And again, our function was written in standard form. So I look up at the function, and I see that a is going to be equal to 1, b is equal to negative 3, c is equal to negative 4. Okay, so I'm just going to plug those into the equation for the axis of symmetry. X is equal to negative b over 2a. And again, it's going to be negative 3 divided by 2. So again, that's 3 over 2 for my answer. X equals 3 over 2, sorry. That's the equation of the vertical line. That is the equation for the axis of symmetry. Okay, so this is the vertex down here. We need to find the y-coordinate to finish the last question. So all you have to do is plug in 3 over 2 into the original equation, and you'll get the y-coordinate is negative 25 over 4. Okay, so that's how you do this question algebraically.